Okay guys, good afternoon. We are talking about of the thermodynamics and some one concept, okay? The team members is Jaime Sáenz, Irvin Urbina, Elias Íñigo, and me, Jesus Gutierrez, okay? The first concept. Types of thermodynamic processes, okay? Number one is isothermal, process at constant temperature. The second is isobaric, process at constant pressure. The three is isometric or isospheric, process at constant volume. The number four is isenthalpic, process at constant enthalpy. The number five is isentropic, process with a constant entropy. Okay. And the first concept is what is isothermal. Okay. It is the compression process by which the temperature is kept constant but the volume and pressure vary. Okay. For example, in this picture we can see how temperature is constant, okay, but the volume and the price vary. Okay. For example, this picture represents the volume and the pressure. The second concept is what is isobaric. It is a compression process by which the volume and temperature of a controller gas while the pressure is kept constant. Okay. An everyday example of an isobaric process is presented by the boiling water in an open container by supplying heat energy to water. Okay, it rises.
Hello guys, continue with the presentation. The other topic is what is the adiabatic. An adiabatic process, this one occurs without transferring heat or mass between a thermodynamic system and its surroundings. Unlike an isometrical process, an adiabatic process transfers energy to the surroundings only as a work. Is one in which the thermodynamic system, normally a fluid that doesn't exchange heat with the environment. An adiabatic process that is also reversible, it's known as an isentropic process. As you can see here in the view, this one that is down of the pressure and that is down of the pressure and volume that is here, that blue color, and that is the adiabatic. If we have a piston with some gases and the piston take out of the gas, we can know that the pressure is less and the volume is more because it's going to take out the piston, so we can obtain more volume. So if we have less volume, no, less pressure and more volume, the temperature is going to decrease. So if the temperature is hot, when the piston take out, uh, because it has a less pressure and more volume, the temperature is going to pass of the hot to cool. Is an isometric process. J equal to Cp divided by Cv, as seen when studied the relationship between head and work. This is the law that governs quasi-static adiabatic process as an important particular cases. For I, J equal to 1.4, it is a constant volume process. As you can see here in the figure image.
Okay, hello everyone, my name is Iñigo. I will explain by part according for there is the three types according for the thermodynamic system. We do remember the topic is thermodynamic system. The thermodynamic system is made for two words. Okay, the first one is system. Okay, the system is related for the group. And the other thermodynamics is for according for the other weight in the science. Okay, the science is possible find in chemical and physics. Okay, and for these things is important obtain the knowledge according for the different explains different examples for these parts. Okay, is the isolate system. Okay, the isolate system for the other ones in this part, if it cannot change the output and input according for the mass and heat. Okay, is more common in the laboratories in the chemical. Okay, I can't find the other example, but in these parts the only difference is cannot change. Okay, and this diapositive we can watch the mass, we can the volume over the pressure. Okay, this characteristic is according for the the principal behavior according for the system. Okay, with the three. And now we have three types according for this system. Okay, the first one is open, the second one is closed, and the other one, and the last one is the isolate. Okay, the first one is an open system, and in this part we can obtain the third characteristic is when these parts it can be it can be out and input according for the mass and energy. Okay, this example is possible relationation obtain the relationation according for the car. Okay, when we driving the car, it's possible go out or go on in this thing. Okay, this example is possible relation put the relation for the mass. Okay, and the mass and the other one, when we have a day, a cold day, we body have a heat, okay, and we system this case is a car. When they enter, it's possible give the transmission for the energy. And the energy in this case is the heat. When we on in the car, we on the energy. Okay, into these parts we have a little diagram according for the for the three types thermodynamic system. The system is possible find a thing, or in this case is in a car, include into all universe. Okay, the system is the place according for the relation, and the proposal is the obtain the knowledge for the behavior and the behavior and the other behavior. Okay, the second one is system close. Okay, and the system close and this parts is more similar, have a characteristic like the first one. Okay, but in this part, this system it can't give the transmission according for the mass. Okay, for both example, it's possible give the relation according for the thermo. Okay, the thermo is in the same occasion. We can drink a coffee and the other one. Okay, and this thing is possible conserve the heat into a lot of time. Okay, for this reason, it's possible give the relation for the closed system. Is the isolate system. Okay, the isolate system for the other ones. In this part, if it cannot change the output and input according for the mass and heat. Okay, is more common in the laboratories in the chemical. Okay, I can't find the other example, but in these parts the only difference is cannot change. Okay, and this diapositive we can see, we can watch the mass, we can the volume over the pressure. Okay, this characteristic is according for the the principal behavior according for the we system. Okay, with the three.
Good morning, guys. My name is Jaime Sainz, the team number 1. I am explaining about thermodynamic variables that intervene in the systems. The thermodynamic variables are state variables, are the questions that are used to describe the state of the thermodynamic system. Depending on the nature of the thermodynamic system under study, different sets of thermodynamic variables can be chosen to describe it. In the case of the gas, these variables are mass, m or n, is the amount of substance that the system has. In the international system, it is placed respectively in kilograms or in number of moles. Volume is the three-dimensional space that the system occupies. In the international system, it is expressed in cubic meters. Although the liter is not a unit of international system, it is widely used. It is conversional to cubic meters is 1 equal 10 minus 3 meters cubic. Pressure. It is the force per unit are applied on a body in the direction perpendicular to its surface. In the international system, it is expressed in pascals. The atmosphere is commonly used in of pressure. It is conversional to Pascal. Is a 1 atm 105 Pascal.
Okay, and this part is for the conclusion. The conclusion is very, very important. Obtain the knowledge for give a service. Okay, obtain the technology for the behavior for this reason we are the investigator, we are the scientific. For the three types according to these systems, we can make machines. For example, for cars, the cars is possible to find a lot of systems according for these three types of systems. Okay, is my conclusion, and thank you for watching this video.